You're about to leave Earth with a real chance of not returning, but your enthusiasm gets the better of you, ignoring all the risks. In the background, you hear the countdown, and only then do your hands start to sweat, and you begin to question whether you made the right decision. Now it's too late. The rocket begins its journey towards a place where sound simply ceases to exist, because there's no air to vibrate, and you go anyway. That's what the 4 Artemis II astronauts heard when they crossed Earth's orbit in April 2026. For the first time in 54 years, humans have gone beyond our planet, even with all the technological advancements. The world stopped to watch, real-time broadcasts, constant communication with the crew, and spectacular images. It appeared to be the safest flight ever undertaken. But nobody told you the real risks. The reality is that danger always exists. It's there, waiting for the right moment to act. The dream of exploration can change when you know exactly what happens to astronauts before and after space exploration, and how it impacts our lives down here as well. You're driving home at over 40,000 kilometers per hour. That's far more than a commercial airplane can reach. It's 40 times faster. No body could survive that. An airplane travels at 900 kilometers per hour, but the Orion capsule returning from the moon, it travels at 40,000. And between you and that speed, between you and death by heat, there is a layer of material a few centimeters thick that guarantees survival. But unfortunately, the material cracked during Artemis I, a mission carried out in 2022 without a crew. Sadly, Orion's heat shield eroded more than it should have. At least there were no humans on board this mission. But if we had been, a movie would have played in our heads at over 40,000 kilometers per hour. NASA didn't know exactly what happened to Orion. Then, on Artemis II, they reversed their trajectory, using the gravitational field to their advantage. A strategy that, instead of bouncing through the atmosphere, resulted in a much more aggressive direct fall. But here's the paradox. It was the first time they tested this entry system with people inside. Nothing beats a first time completely without testing, just calculations and a lot of technology. They didn't know if the safety test would work until they actually tried it. In 2028, on Artemis IV, the rate of return will be even greater. The redesigned shield will be tested for the first time on a real lunar mission with astronauts on board. That moment, when you're sitting, talking, observing Earth from space, you can't see, feel, or even hear, but at this very moment, you are experiencing it from the inside. On Earth, we are lucky. The planet's magnetic field deflects most of the deadly particles that the sun sends our way. But when you leave low orbit, that shield disappears, and we're completely on the front line against danger. The Apollo astronauts received doses of radiation during 1-2-day missions. Decades later, studies showed high rates of cataracts among them. Research has shown that exposure increases the risk of cardiovascular disease. Artemis IV will put astronauts on the lunar surface for a week, where your body will not be able to withstand it, because on the surface, without an atmosphere, the daily dose is 200 times greater than what you receive here on Earth. And there's another problem. You can't predict when the sun will explode. In August 1972, between Apollo 16 and 17A, one of the biggest solar storms of the century occurred. If someone had been on the moon at that moment, the dose would have been potentially fatal, a matter of months difference. Dust is probably one of our biggest inhibitors on the moon, said Gene Cernan, after walking on the moon during the Apollo 17 mission in 1972. The guy had just walked on the moon, and the most immediate problem was the dust. On Earth, dust becomes rounded off by wind and rain. The moon has none of that. Each grain is a fresh fragment of pulverized rock, with edges like broken glass. It has an electrostatic charge that makes it stick to absolutely everything. The Apollo astronauts called it lunar hay fever, irritated eyes, itchy throat, sneezing, after 3 days on the surface. Researchers exposed human lung cells to simulated lunar dust. Result: cell death, DNA mutations, risk of cancer. And the worst part? NASA knows it won't be able to eliminate the exposure. Because dust gets into the mechanisms of the suits, eats away at the seals, and when the astronaut enters the lander, the dust goes in too. All 12 who walked on the moon experienced symptoms, 100% rate. In this case, it's best to avoid contact by staying well away. For billions of years, the sun has been sending particles toward the moon. With no atmosphere to filter, no magnetic field to deflect, these particles became embedded in the soil. One of them is helium-3. Across the entire Earth, less than 25 tons available. On the moon, estimates suggest up to 3 million tons. Why does this matter to you? Helium-3 is fuel for nuclear fusion, clean energy, with no radioactive waste. 25 tons of lunar helium-3 could supply the entire energy demand of the US for a year. And it's a critical component for cooling quantum computers, technology that will define the next decade. The 1967 Outer Space Treaty states that no nation may possess the moon. But it doesn't prohibit mining. The US created the Artemis Accords, which 61 countries signed. But guess what? Russia and China didn't sign. They have a parallel lunar program, with plans to establish bases at the lunar South Pole by 2030. The same place where the US wants to land in 2028. There is no clear spatial law. There is no referee. First come, first served, and install the equipment. It will give you an advantage that will be difficult to overcome. This is not science fiction. This is international politics happening right now. Artemis 2 orbited the moon a few days ago, on the 11th of April, 2026. The 4 astronauts are alive, and the heat shield is currently being analyzed, because what they find there determines what happens next. Artemis 3, mid-2027, but still without landing, will serve to test the docking with commercial landing modules, SpaceX's Starship HLS, and Blue Origin's Blue Moon, and it will debut the new lunar suit developed by Axiom with Prada. And the new lunar suit makes its debut developed by Axiom with Prada. The most expensive outfit in history bears the signature of Italian fashion, because resistance to lunar dust and ergonomics matter together. Artemis 4 will be released in early 2028. This will be the big moment. The first human landing on the moon since December 1972, more than 55 years have passed. There will be 2 astronauts on the surface for a week. At the South Pole, where the ice is, lies the most unknown dangers. Craters that have never seen sunlight, ground that no human has ever set foot on. And the redesigned heat shield will be tested at true lunar speed. For the first time, with people inside. If it works, history. If it doesn't work, that's why NASA tests everything in order. Let me show you the pattern. Did the shield crack? Did Apollo 1 catch fire? And we learned how to build better hatches. Did the radiation cause cataracts? And we learned how to monitor exposure. Did the dust get everywhere? And in 2028, we'll have new outfits, new filters, new protocols. The struggle for the moon's resources, Antarctica has a treaty. The high seas have a treaty. Lua will have one too, eventually, after a lot of tension. Exploitation has always been like this. You go, you almost die. You discover what you didn't know. And the next time someone goes, the risk is a little lower. In 2028, someone will set foot on the moon for the first time in 56 years, and nobody will know if it will work until they take the first step. That is the definition of exploration. It is not the absence of risk. It's a decision about whether the risk is worth it.